Boom. Okay. Today is January 8th, 2013. We are going over page 100, number 27. Okay. Two snowcats tow a housing unit to a new location in Antarctica. The sum of the forces on it. Okay, here's the housing unit. We're just going to treat it like a body. I'm not going to draw the housing unit or the snowcats, but they say that there is F sub B is pulling at a 30-degree angle to vertical, and force sub A is pulling at a 50-degree angle to vertical. Is that correct? Okay. They also say that okay, the sum of the forces exerted on the unit by the horizontal cables is parallel to that. It's vertical. And they say force sub A is 4,500 newtons. Correct? And they basically then say from that to figure out everything else. All right. Which way is this thing going? And that's where the drawing's not to scale, but which way is this thing supposed to be going?
Forward. That's the wrong word, but
Okay. So it's got to go this way.
right.
You're trying to figure out.
Now, the problem doesn't say that it's on a rail or it's got a steering mechanism. So if it's going straight, if you're applying forces to something to make it move, and it's going straight up this way, what must be true about the forces to the left and the forces to the right? Equal and opposite. So this component and this component have to be the same. That's your big clue here. Force sub A, if I break it down into its components, it's got 4,500 cosine. Cosine of what angle?
50.
Force of A. Whoops, sorry. Did they say force of A was 4,500 newtons? And that force of A going that way. Okay, yeah, 4,500. Is it cosine 50 degrees?
No, it's 40.
What's its standard angle? It's 4. Okay, 40 will get you. Okay, let me slow down a little here. Tyler just correctly stated that this reference angle will be 40 degrees. And we can use 40 degrees. We can use this 40-degree angle with this cosine, but then what else do we have to do?
Negative.
We would have to make it negative, because this force is going to the left in our drawing. If we didn't want to use the negative sign,
I got you.
what angle would we have to use?
That would be 140.
140. Tyler's remembering his trig very well, because we could also use the standard angle. We could go back here, go 140 degrees. I don't have a preference. I'm going to make this negative 4,500 cosine 40 degrees. And then the vertical component is positive 4,500 sine 40 degrees, because going up is positive in our diagram. Any questions on that? How I set that part up? Does that accurately describe force sub A? Okay, now here's all we know about force sub B. I'll write that here, but I'm going to fill this in as we go. Okay, what do I know about this? Let's see. This part, the horizontal component.
But didn't you say that force of A and force B have to be equal for it to be moving up?
Bingo. This is the here's force sub A in the horizontal direction. Here's force sub B in the horizontal direction. They have to be equal and opposite So force sub B in the horizontal direction is going to be 4,500 cosine 40 degrees. Is it acting at a 40-degree angle, though?
No, it's like a 60 degree.
Very good. It's acting, if we go back to our unit circle,
Right.
it's acting at this 60-degree angle here.
And it's on the first quadrant, so both of them could be positive. As well as cosine and sine.
So if we'd been given force sub B, we would have found this by doing force sub B cosine 60, right?
Right.
Okay? So it's force sub B cosine 60 degrees, force sub B sine 60 degrees. Can we find the magnitude of force sub B from this information here?
Yeah.
Yeah. It's 4,500 cosine 40 degrees divided by cosine 60 degrees. Who's got a calculator and can tell me how big that force is?
That would be 6,894.4.
6,800 and what?
94.
0.4 newtons is going to be your force of B. It does make sense that it should get bigger with that.
Because it has to compensate for the
Right.
bigger degree of that other force.
This drawing's really not, well, yeah, my drawing's really not to scale with the forces at all, for this thing to go straight. Okay, that was one of the questions. It said find force of B and determine the magnitude of both forces. The magnitude of both forces, do we have to care about the left or right part? No, the key is knowing this thing is going straight. So since it's going straight, and they don't mention anything else keeping it going straight, force of A plus force of B is going to be right there up the middle. These are going to be equal and opposite and will cancel out, so all we have to do is add up our vertical components, and now we know the magnitude of F sub B. So force of A plus force of B, just the upward parts, is going to be 4,500 sine 40 degrees plus 6,894 sine 60 degrees. Did I fill that in correctly? Maybe? Yes? No?
Yes.
Did you put the .4?
I did not put the 0.4. That's true. Good eye for detail, Robbie. Might make a difference. Somebody put in the 0.4. Tell me what this number is.
I did both. So with the .4 would be
8,868.26.
and
27.
8,800
63.27.
and without it would be 8,862.92.
So either way, the three significant digits, it's 8,860 newtons. Correct? And actually, they only gave us two significant figures in this problem, didn't they? With just the 4,500 newtons.
So to that it would be 8,900.
Yep, very good. It'd be 8,900 newtons with the correct number of sig figs, because all they gave us was this, the 4500, and the zeros don't count. So our two answers are 8,900 newtons for the sum, and for force sub B, the two significant figures would be 6,900 newtons.
Wow.
Any questions on that one?
Can you wait just a moment to erase it?
Yeah, I'll wait a moment to erase it. What was the other one I assigned?
That was it.
24.
24?
Yeah.
Okay. 24, we're just adding some components together.
That one was easy.
Hope so. 24, I'll take a look at it in a sec. I want to make sure everyone got it right. And then we'll,
Can you email us
yeah. Well, actually, I'm hoping to put it on my web page, if it uploads fast enough. Yesterday should be ready, but it was still, I wanted to wait till it was done processing to make sure it was good. All right, how we doing? Let me know when can I erase this yet?
No.
Nope, okay, I won't. We've got to get a real tripod again so that we can turn it and use both boards.
That thing has wheels.
It's a little unstable. All right, Danny, I'm going to start erasing the drawing, okay?
Oh, you can erase that one.
Thank you.
You can erase everything except the two box things and the thing in
Okay,
equal sign above it.
gotcha. All right. So now for number 24, I'm just going to jump right to the drawing. It's on page 99, and it says the two forces shown. And in the first drawing, F sub 1 is headed straight to the left, and F sub 2 is heading down. And they give magnitudes of,
Should we, were we to assume that this was quadrant 3?
yes, but okay,
Here is
here's
all
the,
that.
thank you. They give the mass of a 27.0 kilogram object, right?
Right.
Okay. And then, how big do they say F sub 1 is?
Well, 10.2.
Newtons.
10.2 newtons, and what's F sub 2?
16.0.
Okay, if we look at this, these two vectors in component form, bless you, this would appear to me to be the vector F sub 1 looks like it's negative 10.2 newtons going to the left, that's why I made it negative, and 0 newtons up or down, correct? And this one, F sub 2, looks like it's not going left or right, it's just negative 16.0 newtons going down. So if I add these together, I get negative 10.2 newtons, comma, negative 16.0 newtons, just adding their components. You guys with me so far? All right, what's the magnitude of that vector? The magnitude of F1 plus F2 is going to be the square root of negative 10.2 squared plus the square root of negative 16 squared. Square root of 300. So that's 17, 18, somewhere around there?
18.9.
18 point, no, 19.
19.
18.97.
So it's 19.0
Yeah.
with three sigmas.
Yeah.
Okay, so 19.0 newtons. Now, do they ask what direction it goes in?
No.
Just says find the net force, so we don't have to worry about theta. If we were looking for the direction, we would do the inverse tangent of 16 over 10.2, but it's not. Okay, so if 19.2 newtons is acting on a 27.0 kilogram mass, since force is mass times acceleration, we can find the acceleration on the object by dividing 19.2 newtons, because a newton is a kilogram times a meter times second squared, and divide that by 27.0 kilograms, and all that's left is meter per second squared. Jake, let me get this answer, and then I want to hear your question. What is this answer? Okay, so 3 sig figs, 0.771 meters per second squared. Jake?
I tried using the Pythagorean theorem because I recalled yesterday you talking about when Diego asked.
Yes. That's
And
what...
I got, in specifics, 18.97 newtons, but if rounding it up, it would have been the same answer.
Yes. Yeah, so when you go to 3 significant figures, I probably went to 3 significant figures early. I probably should have used 18.97 here, and I miswrote it as 19.2. Diego, please tell me you use 19 and not 19.2 or 18.97.
No, I,
0.703.
0.703.
Yeah.
Jake, thanks for saying that and helping me catch that mistake. Yes, Danny.
Is this part A or B? Because this is what I got for part
This is part A.
B, which means maybe I mixed them up.
It could be the same acceleration. You can get this
No, I-
acceleration different ways.
Think so.
Okay, this is part A. I should have labeled that. And I didn't quite leave myself enough room to do part B. So let me know when I can erase this. I'm good?
Yeah.
Okay. And now part B.
Which is the same problem, which is different.
Yep. Same vectors, different directions. So this one for part B, which one's going up, F1 or F2?
F1, I believe.
And that's the 10.2 newtons.
Yeah.
And then they say F2
I don't remember
is going at a 120 degree angle here. And the magnitude of F2 is 16.
No, F2 is going down, up, sorry.
And F1 at 10.2 newtons is going this way.
And that was 16.
Awesome. 16.0 newtons. Okay. When I've split these into components, the top one is not, F2 is not going left to right. It is going up. Second one, I have to pull out some trig. What's the angle we use to describe what F1 is doing? We have two different ways we can describe that.
30.
Okay, so if we use a 30-degree angle down here, then if we use 30 degrees, we have to keep track of the positive or negative ourselves.
Probably 330.
Or we use 330 and then we don't. I'm going to use 30 and keep track of the positive negatives myself. It looks to me like it will be described by 10.2 cosine 30 newtons positive x and negative,
Why?
yeah, y, negative 10.2 sine 30 newtons going down. And we add those together. And I have no idea what that is. Well, actually, the first one I do. First one, when I add them, I just get 10.2 cosine 30 degrees,
Which is 8.8.
8.80 or 8.8,
8.83.
8.83 newtons. All right, now what about 16 minus 10.2 sine 30? Actually, that's 1/2. Sine 30 is 1/2, so that's 5.1, so you should get
10.9.
10.9 newtons. Any questions on how we got the vector that describes what this thing's actually doing? Let me show that step. And now, I'll go up here. The magnitude of both forces is the square root of Pythagorean theorem, like Jake said a minute ago. 8.83 squared plus 10.9 squared. 13, 14 something, somewhere in that vicinity. What are we getting here? Who's racing? Come on, Vishal, I want your emulator to win.
14.02.
What do you get?
14.02.
14.0 newtons, we'll say. Easy mistake to make would be circling this and calling it the answer, but the question was, this 14.0 newtons is accelerating a 27 kilogram mass. How much?
You just, divide it, right?
Divide it, yeah, 14 divided by 27.
0.518
Well,
meters per second.
it can be
squared.
5.19.
0.51.
You have 0.5.
0.51, 8 or 9?
9 because the next number's
Oh, yeah.
5.
Yeah.
All right, meters per second squared. that will be the result of those forces. Any questions on those?
No, sir.
Awesome.
Are we doing anything this year?
No, I just want to mix and match this with a little pulley stuff, but all right, yeah, there's a problem I want to look at. Okay, let me know when I can erase this. We all good? Everybody good? Okay. I want to combine some of this with, go back and talk about pulleys some more. And let me take a quick look at this. Wish I weren't recording today, to be honest.
I'm sure Nate's glad to hear that.
Yes, sorry Nate, no
Hi,
offense.
Nate.
I wonder if
No.
Nate has internet and is even watching this.
We'll figure it out.
Yeah, we'll listen to
Okay. There's a couple things I can do. We need to start talking about that soon anyway. Don't want to do friction yet. Okay,
Oh, God.
so actually, you know what? I'm going to not go over these yet. I see two problems I want to give you tonight that we'll talk about. I'll let you guys fiddle with first. So for tonight, page 100, we'll try 29, 30, and 31. They require some thought, and we'll talk about them tomorrow. Okay?
Requires some thought in your options, right?
No.